Alright. So in the previous few videos, we've had a look at different ways of creating NumPy arrays. We've seen how we can view them. Now let's figure out the fun part. Let's figure out how we can manipulate and compare our different arrays. This is where the crux of machine learning happens, right? It's manipulating, performing calculations, finding patterns in arrays of different numbers. So let's start it off. We'll put in another heading because we're keeping our notebooks nice and neat. Manipulating and comparing. Have I spelt it right? I usually get typos in these headings. Manipulating and comparing arrays. Beautiful. We're going to put a little subheading here because, like pandas with NumPy, if you can think of a way of manipulating numbers, you can probably do it. So the first one we're going to look at is arithmetic. There we go. Lucky my coding is a little bit better than my spelling ability. But arithmetic is a fancy word for basic math equations. So let's have a look. We'll start off by checking out our A1 array. We created this earlier. A1, wonderful. We'll create another one called ones. Actually, we've already got ones. Yep, beautiful. But if you wanted to recreate it, we'll go np.ones3, just to make sure we know what it looks like. Ones. Wonderful. Okay, first one we're going to have a look at is nice and simple, plus. So what do you think this will do if we go A1, which is our array here, plus ones? Well, let's not talk about it, Daniel. Let's run the code. Beautiful. A1 plus ones. So we've got 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 1 equals 4. Excellent. So all this has done has just added together the different elements in the same position of both arrays. So the 0th position, 1 plus 1 equals 2. The first position, 2 plus 1 equals 3. And the second position is 3 plus 1 equals 4. All right, well, let's keep going. Let's see a few more options. A1 minus ones. Can you guess what will happen here? 0, 1, 2. So all it's done is it's subtracted ones from A1. Let's push forward. Let's try and multiply. A1 times ones. Yeah, well, that makes sense because our ones array is just all ones and it's just times A1 by 1. 1 times 1 is 1. 1 times 2 is 2, and so on. Let's bring in another array. A2, here we go. Now this will be interesting. If we multiply A1 by A2, what's going to happen? Let's see. Let's work through this. So we've got 1. Let's get up A1 again so we can see everything in one place. A1. 1 times 1 is 1. 2 times 2 is 4. 3 times 3.3 is 9.9. That makes sense. But what about this second row here? Let's see if we can figure this out by looking at it. 1 is 4. 4. 2 times 5 is 10. Yep. 3 times 6.5 is 19.5. Let's use Python to help us out for that. 6.5 is 19.5. We can get rid of this cell. We don't want that. Actually, never use a toolbar. Escape X to get rid of that. So what this has done is it's taken A1, these three numbers here, multiplied it by this row, put it in here, and then done the same thing again with A1 and multiplied it by this row. That's interesting. Let's have a look at our other array first, A3. Let's combine these two, A2 and A3. A2 times A3. Operands could not be broadcast together with shapes 2, 3, 2, 3, 3. Operands could not be broadcast together. That's interesting. Well, remember right at the start, at the concept video where we talked about when NumPy is fast because it vectorizes code through a technique called broadcasting. Well, this is what's happening here. But to be that fast, broadcasting has a few rules. So let's look that up. NumPy broadcasting. There we go. We're going to go to the documentation, broadcasting NumPy. Click on that. The term broadcasting describes how NumPy treats arrays with different shapes during arithmetic operations, which is exactly what we're doing. We're trying to use some arithmetic on arrays with different shapes. So there's A3 and there's A2. They've got different shapes, and that's what the error's coming up. So let's have a look here. Subject to certain constraints, the smaller array is broadcast across the larger array so they have compatible shapes. Well, that explains what's happened up here with A1 times A2. The smaller array is broadcast across the larger array, so they have compatible shapes. That makes sense because we've got here, this is a smaller array. It's been broadcast across this row and then across this row so that the output has a compatible shape of the larger array. Okay, we'll keep going. There's some examples here. So these are two arrays multiplied. They've got the same shape. 1, 2, 3, 2, 2, 2. A times B is 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. That makes sense. And then broadcasting rule relaxes this constraint when the array shape meets certain constraints. Okay, so this is good. This is the kind of workflow you want to start getting into, right? Is if you come across an error like this, and you will all the time, one of these mismatched shapes errors, like different shapes that are incompatible with each other, a value error, these are going to come up all the time in machine learning. And part of being a data scientist or a machine learning engineer is reading documentation like we're doing now and trying to figure out how to fix our problem. So general broadcasting rules, okay. When operating on two arrays, NumPy compares their shapes element-wise. It starts with the trailing dimensions and works its way forward. Two dimensions are compatible when they are equal or one of them is 1. Now, to save a little bit of time, instead of going through the entire documentation, I'll leave that for you. I want you to have a think about, try and figure out a way, how would we get these two to be of compatibility? How would we fulfill this broadcasting need? So what you may want to look into is how can you reshape A2 to be compatible with A3? So that might be looking at search, put in another comment here, how to reshape NumPy array. So check out the broadcasting documentation along with searching something like this, and then figure out how to make these two shapes align. If you can't, that's entirely fine, right? This takes a bit of practice, but we're going to see how to do it in a future video. Right now, we're going to continue with our arithmetic just to finish things off. So where were we? We've done multiplication. Let's try A1 divided by 1s. So this little slash is for divided by. And you can probably predict what's going to happen here. Beautiful, it works fine because our arrays are similar shapes. Okay, let's try A2. Let's try some floor division. A2 divided by A1, wonderful. But we'll see what non-floor division works here. There we go. So floor division, what this means, if you do two slashes, you might have seen this in Python. If not, that's fine. Floor division removes the decimals. So you can see here, it rounds it down. Rounds down. So 1.0, 1.0, 1.0, 1.1, but that's been rounded down to 1. 2.166667 has been rounded down to 2. Let's keep going. What have we missed out on? Let's go square. A2 square 2. This is a power, so to the power of. So everything in here is going to be to the power of 2. So if we look at A2 on its own, it's going to be 1 times 1. 2 times 2 is 4. 1 times 1 is 1. 3.3 times 3.3 is 10.89. We'll confirm that with Python. Wonderful, 10.89. That's just filled it in there and rounded it off. Actually, NumPy has a square you can use with this. So all of these functions that you see here, that we've gone through, arithmetic, floor division, etc., NumPy has the equivalent here. Now, which one should you use? Well, it's going to depend on what your workflow is best at. So if you want to use the math symbol operations, you can use that. Or if you want to use square, or you can even go np.add. You're going to go shift tab to figure out what it does. Let's figure out here, docstring adds arguments element-wise. So let's try that, A1, 1s. Same as just doing A1 plus 1s. Wonderful. We've got a couple more. A1 modulo. This is going to show us the remainders. So A1 divided by 2. Let's see where that goes. A1 divided by 2. Let's go NumPy modulo. mod. There we go. Return element-wise remainder of division. Wonderful. So this is, again, I'm trying to exemplify the kind of workflow you go towards. If you're not sure what something does, you can always look up the documentation and have a look. That's what we did with broadcasting. We've just done that with modulo. If we divided every element in A1 modulo 2, it's going to show us the remainder that's left over. So let's do A2 modulo 2. So this is just showing us the remainder of what's left after we've divided everything by 2. And if you wanted the exponential, if you're not sure what this is, don't worry for now. It's just to highlight the kind of arithmetic that you can do in NumPy. This is going to take the exponential of everything in an array. And if you want the log, you might see this come up in future projects of an array. You can use np.log. So that was a bit of a whirlwind tour of some of the arithmetic functions that you can do in NumPy. Remember, if you can imagine it, you can probably do it. This is only just scratching the surface. So before next video, have a practice around creating some of your own arrays and then using some of these arithmetic functions on them. Remember, if in doubt, run the code. If you're not sure what something does, have a look at the NumPy documentation, see if you can figure it out. I'll see you in the next video. We're going to cover a little topic called aggregation, but we'll save that for the next video. See you soon.